Physics Part 26. The thermocouple thermometer actually measures the difference in the temperature between the junction of two metals, the hot junction and a cold junction. In some application, the cold junction is placed in an ice water. In an ice water mixture so as to achieve a known reference. The thermocouple may be connected to a millivoltmeter which has not been calibrated in temperature units. In this case, you will have to make use of the known variation of thermoelectric EMF for that particular pair of metals with temperature. You will need to draw a calibration curve, a graph of temperature against EMF, so that you can read off the temperature corresponding to an EMF reading. Note that this graph is often a curve rather than a straight line, as shown in figure 2.31. In some cases, the curvature is so much that a particular EMF can be obtained for two different temperatures. Clearly, this restricts the temperature range over which the thermocouple is useful. Choice of method. The heat capacity of the bulb of a liquid in glass thermometer is much greater than that of a hot junction of a thermocouple. For this reason, the thermocouple is particularly useful if a rapidly varying temperature is to be measured, or if the object, the temperature of which is required, has a small heat capacity. Mercury in glass thermometer are available to cover the temperature range from about minus 40 degrees Celsius to 350 degrees Celsius. Thermocouples using different pairs of metal or alloy, pairs of metal or alloy wires can cover a much larger range. The choice of a particular thermometer in a given application will depend on the range of temperature to be covered, the heat capacity of the object, and whether the temperature is varying rapidly. Methods of measuring current and potential difference. Your physics laboratory will probably have a selection of instruments for measuring current and potential differences, difference voltage. The two main types of the analog meters, in which a pointer moves over a scale, and digital, in which the value is displayed on a readout consisting of a series of integers. Analog meters. The analog meters, and then there are digital meters. The analog meters, the normal analog meter is restricted to the measurement of the relevant quantity over a single range. For example, a 0 to 1 ADC ammeter will measure direct currents in the range from 0 to 1A, A0 minus 30 VDC voltmeter will measure steady potential differences in the range of 0 to 30 volt. Some analog meters have a dual range of facilities. with a common negative terminal and two positive terminals, each of which is associated with a separate scale on the instrument.